mean networking.
Fat Finger Squad. What it do, baby? What happened to my live stream chat over here? What's going on, Danny? How y'all doing today, man? Today's lab is OSPF and point-to-point networks. I'm gonna go ahead and fire up GNS3. I downloaded. Actually, I had a router that did have these serial interfaces. That older router that was running version 12. I'm pretty sure it should run well for this lab. We only got two routers for this lab here. We're gonna give it a couple minutes for some late stragglers to come in. Y'all know he's talk shit for about the first 10 minutes, and we usually wrap it up in about an hour, unless we got some troubleshooting to do. This man with the bruhs. You like that little remix I did? Remix! I heard the beat going, I was like, bruh. Bruh. Today's lab, again, is configuring OSPF on point-to-point networks. So, this is the first time, I guess, they introduce OSPF in the book. It's lab number 47 in the book, page number 203. If you guys are following along for the first time, well, I'll talk about that in a little bit. There's only a couple of y'all in here, but I'll introduce the book in a little bit. But yeah, page 203 in the lab guide, lab number 47, configuring OSPF on point-to-point networks. So let's go ahead and get that going. Configuring OSPF on point. I'll put point networks. I guess I'm on packet tracer today. It's all good, man. It's all good, you know. And look at here. Apparently I got an update, but I don't want to do it right now. I'll do it later. It's been asking me about this, and I've been putting it on the back burner. But and typically when I update my GNS3, it kind of breaks, man. So that's why I kind of leave it alone. But yeah, maybe after this lab, after this stream, I'll go ahead and check with you. I'll see if I can update it, and hopefully I don't break it. But again, we only need two routers for this lab. Go ahead and drag and drop router 1 and a router 3 apparently. So I'll do that and then delete the other one. Yeah, the book said router 3. I took a peek at it already. I don't know why they got a router 1 and router 3. I don't know if they did that to throw us off or what. But yeah, router 1 and router 3 is what we're gonna name them. I'm gonna back to back like this. We're gonna get a serial cable going for this guy. I'm gonna go from 2.0 to 2.0. Get the labeling and cabling so we can get this out of the way. Y'all know what I said. We're gonna get the labeling and cabling. We're gonna take care of that off stream once we get to the more complex topics. So that way I ain't not necessarily wasting y'all time, but you know, all of this tedious stuff, we'll get that out of the way. And for y'all that are just tuning in for the first time, y'all can go ahead and hit me with a subscribe, man. Subscribe to this channel, like what you see so far, even though we haven't covered anything yet. Go ahead and join the Discord server if you haven't done that yet. There's a link in the description in the chat box right there. This lab is gonna be in the 172.16.1.0 network. Left is gonna be .1, right is gonna be .2. So let's go ahead and do that. And both of these routers are gonna be 16. I said 1.0. Yeah, 1.0. 1.0 network slash what? 24. Nope, slash 26 network. Interesting. Slash 26 network. And again, he's going to be .1 and the other one's going to be .2, right? Y'all with me so far? So he's .1 and other one is .2. I thought there was a shortcut for that, but apparently not. That's .2. Let's see what else we was going to do here. So these routers are going to sit in what's called an area, right? Typically, when you work with OSPF, they're done in areas. And the reason why we do that, remember what we said about routing protocols, right? Routing protocols are a way for routers to share routes with each other. And remember, I always compare networking to roads and highways, right? So we have a router that has a route to a specific destination or network, right? And then he has it on his map or his, his GPS, whatever, because remember, this OSPF is kind of like GPS, right? And he gets that route, and he's going to share it with his neighbors. He's like, hey, if you want to get to this network or this city, take this route. You want to take this network, get to this network, take this route. When we're sharing routes with our neighbors, that's typically what a routing protocol does. BGP does that. OSPF do even RIP does that. We share routes with our neighbors, right? Even though RIP doesn't form neighborships, but they do share routes. So, and when we do that with routers in our area. Typically, OSPF starts with what's called the backbone area. That's area 0. So, since we're only working with just one area, and that's what you always start with is the backbone. That's why they call it the backbone, because it's like the center of the OSPF network. So, we're only dealing with 2 routers here. They're going to be neighbors with each other, and that's what we're going to do in this lab here, I believe, because I haven't done it yet. And then they're going to be in that same area. So let's go ahead and I'll do this just to make it kind of visualize it, make it a little easy. I ain't got to do this, but I'm gonna do this just to make it a little easier for some people that might not understand areas and stuff like that. So we're gonna change his style. Let's go with the fill color. Go with my daughter's favorite color here. Let's go with pink. We'll go with a pink there. That's the fill color. And then we'll apply that. We'll back him up. Back that ass up. Just the one low. And then these 2 guys right here are in that area. And that, again, the area 0 is called the backbone area. That should have been my pop quiz, but that rolled off to my tongue so easily I can't pop quiz y'all now. So we'll put a note there. And remember, these guys are in area 0. So remember that, right? The backbone area. I'll even put that so in case some of y'all need to remember that. Backbone. I remember writing some notes. I looked at some old notes that I had, and I actually drew a bone next to area 0 for me to remember that. That's called the backbone area. I drew a bone. I'll show y'all one day maybe. I think I put it on my Twitter. If y'all follow me on Twitter if y'all want to do that too. At NetworkBruh. Let's go ahead and. Do I need a console in these bad boys already? I think that's pretty much it as far as the labeling does. As far as the labeling goes, this guy's gonna be doing the clocking. I just saw that on the topology there. Let's go ahead and console. Well, we need to power these bad boys on before we do that. Console into them. Plant-based brother said he needs job advice. I am having trouble deciding. Any help from the fellas would be appreciated. I'll post in the Discord for sure. Plant-based brother, I will holler at you. I guess maybe after the live streams, I want to do both of them at the same time. But yeah, I needed some job advice too at one point, man. Probably about 2 months ago, man. I had a decision to either pretty much stay as a network analyst for this hospital system, right? But we was just an analyst. We were just pretty much copy and pasting configs, really. We had to change maybe some of the IP addressing and some of the trunk interfaces and stuff like that. And there was a little bit we were doing with firewalls and stuff like that, and a little bit of wireless or whatever. But for the most part, we weren't necessarily engineers. But it was decent pay. And I had to choose that between that or become a network engineer. But the responsibilities were just a little bit less. When I wouldn't even say it was a little bit less. It's just that there was a couple other pros and cons. There was pros and cons to both of them. So I had that decision to make between both of them. I was in a good spot though because they both of them really wanted me, but I ended up with the network engineer role because I thought it was a better fit for my career, and that's what I ended up doing. So if you need some help, yeah, hit us up in the Discord and I'll give you what I know, what I feel like it could be good advice. So let's go ahead and console on router 1 and router 3. I don't know if they did that to just throw us off with this odd number right here. Y'all with me so far? Anybody got any questions or whatever other than Plant-Based Brother and his fork of the road that he's at right now with his career? It's only a couple y'all in here tonight. It's all good. We might just start a little bit earlier then because the other day we had a bunch of people in here, man. So yeah, OSPF, in case you guys don't know, while those guys are booting up, is definitely in a routing. It's definitely not a routing exam, but in the CCNA exam. It's in a routing exam too, but there ain't no such thing as a routing exam now. It's the encore exam. It is definitely in the CCNA exam. So if you pull up the blueprint, right? This is the blueprint, CCNA exam version 1. It is not the first exam. They just redid it because they revamped the whole exam, right? And if you scroll down to IP connectivity, section 3.4, configure and verify OSPF version 2. There's also version 3, which is the IPv6 version of it. But today we're covering OSPF version 2, the IPv4 version of it. We are covering right here, this section right here, 3.4b, point-to-point network. So what's a point-to-point network? You guessed it, a point to a point. There's 2 routers in one network. And that's pretty much considered a point-to-point network. So we're going to configure OSPF within this point-to-point network. Again, the area 0 is called the backbone network. And are we powered on and booted up? Zooted up and booted up. We are. We got router 1 there. This guy, is he named router 3 already? Yes, he is. So we don't have to worry about that part right there. In case you guys are following along for the first time, he said I got 2 job offers. So that's what's up. That's what's up. Congrats to Plant-Based Brother. You get a bruh for putting the first comment in there and a couple more bruhs for your 2 job offers and was looking for some advice. I haven't had a job in 3 months. Company 1. I would be working. Oh, okay. That's the Discord server. I'm gonna look at that in a little bit, man. We'll look at that. We'll talk about that in a little bit, Plant-Based Brother. I'm doing 2 things at the same time here. So, router 1. In case you guys are following along for the first time, this book is called. This is where we get the lab guide from, or this is the lab guide we follow. It's called 101 Labs Cisco CCNA version 4. You can get a copy of this from 101labs.net. It's authored by Paul Browning and Farai Tafa. Paul Browning, he used to be in law enforcement for a long time. Then he switched over and started his own IT training company and became an author. Farai Tafa is a CCIE. If you don't know, that's a highly regarded certification in the IT industry. And he's obtained 2 of those, I believe. Experts agree that we retained only 10% of what we read, but 90% of what we do. And that's why I like this book, because it gives us something to follow along, hands-on. You know, we could read theory all day long, but this book right here gives us something to practice that theory, right? So, and our theory. So the lab objective of this guide, this lab here, is for us to learn and understand how to enable OSPF, or Open Shortest Path First, on point-to-point network types. Remember we said, right? This type of network right here is point-to-point. If we had a 3rd router right here, maybe sitting right there, right? And connected it to those, right? That would be 2 point-to-point networks. But if they were all in one broadcast domain, that would be a multi-point-to-multi-point network. So it would pretty much be, that would be a point-to-point, and then that would be a point-to-point. But if we had, like, say, a frame relay switching between the 2, then that would be this point right here, to multiple points, right? So, but in this case, it's just 1 point to 1 point. That's why they call it point-to-point network. Aptly named, right? So these include high-level data link control and point-to-point protocol. I ain't even want to talk about that. They throwing too much at us right here. But They're basically encapsulation types is what they are, right? So lab purpose, enabling OSPF on point-to-point networks is a fundamental skill. OSPF is the most popular interior gateway protocol, and it is imperative to understand how OSPF adjacencies are established on point-to-point networks. OSPF uses the concept of areas, like I mentioned before, right? So notice I labeled this area 0. You always start with area 0 when configuring OSPF in a network. We can have 500 routers right here, right? But we're always going to start with area 0. They're going to start with area 0. If we have too many, if we feel like area 0 has too many routers, well, guess what? We're going to create another area right here and maybe call it area 1 or area 10, whatever, right? And then that will be set like kind of like a broadcast domain of where all the LSAs, or what's called the LSAs, or like the OSPF updates will be broadcasted in within that area, right? And then the LSA, there's different LSA types. They will be flooded within this area, and then the other area, and so on and so forth, right? But always start with area 0, which is the backbone. That's a concept you want to remember, right? What else they said here? In order for 2 OSPF-enabled routers to establish an adjacency, they must reside in the same OSPF area. Well, guess what? These 2 are in what? Area 0. And we're going to make them establish an adjacency, right? They become neighbors, right? I believe that's 2 different things, though. Adjacency and neighborship, right? But we are going to create an adjacency between these 2 neighbors. I mean, these two routers, and they're going to become neighbors. And we'll do that in just a bit here. They must reside in the same area, unlike EIGRP, which uses autonomous system numbers, or ASNs. I don't want to throw too much at you if you're a newbie at this, but just remember that OSPF works with ASNs. So does BGP. OSPF works with areas. Don't get them too confused. So we work with areas with OSPF, right? What else they said? OSPF is enabled using a locally significant process ID, which I'll discuss that once we do the configuration. As a Cisco engineer, blah, 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 blah. We'll skip that part right there. So we use that topology. Configure the host names. We ain't got to worry about that. There's how many tasks in here? We only got 3 tasks to deal with today. And task 1 was already done. Configure the host names. Why? Because they already been enabled. They've already been done, right? Router 1 is router 1, and router 3 is router 3. Don't you love that when that part is done already for you? Task 2. Configure router 1. We'll go to router 1. And we are in router 1 right now. Serial 00. I don't have serial 00. I got 20, right? Your interfaces might be different. Just remember, your interfaces might be different. Mine is 20. The book said this is 00, which is a DCE to provide a clock rate of 768 kilobytes per second to router 3. So, and this is what I didn't get to do yesterday because I didn't have serial. I didn't have the serial interface on this, right? So, we're gonna have one router provide clocking to the other side, right? And I don't know an easy way to explain clocking, but basically we're gonna have one side is called the DCE side, the other side is called the DTE side, or data, I believe, terminal equipment. The other one is data clocking equipment. So one side is going to provide the clocking information to the other side. So in this case, router 1 is going to provide the clocking to router 3, right? And then we have to do that on router 1. And that's what they're asking us on task 2. So configure router 1 on 000. So we'll go ahead into configuration for that interface there. So go to global config mode, interface serial, in my case 2/0, right? And once we're there, they said to provide the IP address first or the clocking? They said the clocking, didn't they? I got such a short-term memory. Yeah, to provide the clocking of 768 kilobytes per second to router 3. So we'll go ahead and do the clocking, and that is easily done with just the clock rate command. So clock space rate, and then from there you put the clock rate. They asked for 768 kilobits per second. I don't know if you could. I might have to convert this from kilobits to bits, because if you notice here, when you put the question mark and do the context sensitive help, it says here, with the exception of the following standard values, which are not subject to rounding, right? So they said they wanted 768 kilobytes per second. Let me do this over again so y'all can see. Right? Let's do this over. Boom. Clock rate, question mark, y'all can see. With the exception of the following standard values. These are the only values we can put in, right? If I put 768, it's not going to take, oh, it is going to take it. That doesn't mean 768 768 kilobytes per second, though. Let me convert that before I make myself look like an idiot here. 768 kilobytes is how many bits per second? Anybody know that? I should give y'all that as the pop quiz. 768 kbps to bits per second. Bits per second is actually 768,000. This is what we needed. I'll show y'all what I did. I just Googled it so I know, because I didn't know that by heart. See, so it could have took the 768, but that's not what we're doing here. Is what we would be doing here is putting 768 bits per second. That's not what they asked for in the book. The book asked for 768 kilobits per second to router 3. So once I had to Google that because I don't know it, right? So 768 kilobits per second. How many bits per second? 768,000. So that's what you got to do. Press that after the clock rate, right? So clock rate that, and it rounded to this number. So there you go. See, I didn't even know that. So you put the 768,000 and then it rounds it to that number. As you can see right here, with the exception of the following standard values, not subject to rounding, accepted clock rates will be best fitted rounded to the nearest value supported by the hardware. So by this hardware, I put 768, which stands somewhere in between there, right? The 768,000, right? No, it's between here somewhere. And the nearest value was this 733, if that make any sense, right? Y'all see that so far? We got Dave W checking in. I always put 64,000 in lab environments. Yes, you could do that too. And that is typically what they ask you to do, which is this right here, which is what Plant-Based Brother said, that value right there. But the book asked for that 768. That's why, and y'all know I like to follow this book through T. You know, I fall asleep with this book, man. Y'all know how Chris Webber used to sleep with a basketball? I fall asleep with this book. No, I don't. I'm just kidding. So, enable PPP on the link. You know, there it is, right? That's point-to-point protocol, right? We want to enable that for point-to-point networks, and it is the type of encapsulation. Let me give y'all the official definition because I don't want to like fudge this one up. Let's do that real quick. PPP encapsulation. Cisco. What is encapsulation PPP method? Encapsulation. No, that's not what I wanted. Cisco PPP. The point-to-point protocol provides a standard method for transporting multi-protocol diagrams over point-to-point links. PPP is comprised of 3 main components, and I don't want to get too deep into that. Just know that it's a type of encapsulation that you use within point-to-point networks, hence point-to-point protocol, or PPP. That's something my daughter says when she needs to go to the bathroom. Enable PPP on the link between router 1 and router 3, and configure the IP addresses illustrated in the topology. It says here, we will cover this in detail later, so just copy my commands for now. This guy. So let's go ahead and change the encapsulation. By default, I believe HDLC is the encapsulation. We can verify that with, let's just do a show interface serial, right? 2/0, and we should see the encapsulation there. Yep, so already right there. See, encapsulation HDLC. So that is the default encapsulation for Cisco devices. They want us to change that to PPP, point-to-point protocol, right? So let's go to global config mode for that interface, right? So we're going to this interface right here and changing the encapsulation to that, for that. Right now it's HDLC, so interface serial 2/0. Remember, yours might be different. Encapsulation, I believe you just do PPP. Yeah. Once we do that, we want to verify our work. Show interface serial 2/0. Y'all with me so far? And now we changed it to PPP right there. Y'all see that? We also know that we've done the clocking with the way we verify that, I believe is, what is that? Show interfaces? I forgot what that is. I always forget what that is. Is it show? It's not show clocking. Show controllers. Show controllers serial 2/0. And that's how you verify what side is doing the clocking, right? And then this command, right? Which one tells us that we're doing the clocking? I want to say is that, but this platform right here don't really tell you. The fact that he's receiving a clock, oh, right there, DCE cable, that lets you know that you're doing the clocking. If you do the router 3, let's do that on router 3 on that side, right? So let's do show interface serial. Show clocking, show clock. No, enter controllers. I'm talking too much. Serial 2/0. And are we doing any clocking there? We don't see any clocking on this side. It says DCE cable, receive clock rate. Let's bring it up and let's see what happens, because it says it there as well. So that proves me wrong right there, actually. Let's do this. Let's do the interface, and then we'll do the IP addressing on it, bring it up, and let's see what that says after that. Because typically it's supposed to tell you whether it's doing the clocking or not. So global config mode, interface serial 2/0. Y'all with me so far? Let me move this out of the way. Cool. I didn't know it would round it off. I didn't know that either, plant-based brother, until I did it right now. And this is why I like labbing. Lab every day. Y'all rub me with that like button if y'all like what y'all see so far. So we're going to do the IP address thing on this side, right? The IP address for this interface right here is 172.1.1/26 is the subnet mask, right? So IP address 172.16.1.1 subnet mask of /26, which should be 255.255.255.128.192. Right? Then we're going to do a no shut to bring it up. That turns it on. Remember, because router interfaces, they're down by default. I say that a million times. Then we want to verify our work with show interface serial 2/0. We'll see right there. We did the IP addressing correct. So with the correct subnet mask. Where can you verify the clocking though? That's what I can't remember. That's the one thing I can't remember. And notice that it's up, down. It's supposed to say up, up, right? You know why? Because this one is down still. That is not going to come up, up. It's not going to be fully up until that side is up. We haven't worked on that one yet, right? So, let's do show controllers again real quick and see what he said. It still says DCE and then the receive clock rate. He's supposed to be receiving the clock. So, let me not get too much into clocking here. We came for OSPF, not no damn clocking. But and then serial interfaces are typically, that's like going to the wayside. But I want to experiment a little bit more with that, so I can explain it more better for you guys. Task, we're still on task 2. We still need to do the IP addressing on router 3. Also, we got to do PPP on that side as well, right? So we got to do the encapsulation PPP on this side as well. As we don't have to worry about the clocking because he's doing the clocking. That's gonna be the clocking side, remember? So we're gonna go in this interface and bring it up and also do the IP addressing. Y'all with me so far? We got my man Gonzalo representing Buenos Aires. We got the rest of the Fat Finger Squad checking in. Configure terminal. Y'all subscribe if y'all new to this channel too. Interface serial 2/0. His IP address is. And y'all remember, once we get past this part, I'm gonna skip the IP addressing. So catch up now while this stuff is easy. 172.16.1.2, right? For that interface right there, right? And then we're gonna no shut it to bring it up. And then verify our work. And then we're gonna run another show command to verify our work again, right? Verify, verify, verify. 1.2. He said not 168, right? 16. Okay, good. 255.255. What I said, 192 last time. No shut to bring it up. Encapsulation PPP. He is up, and now if we go, you know, notice these log messages that lets you know he's coming up. And if we go back to router 1, he's gonna get that log message to let him know it's up too. And we can verify that with show interface, right? Because I'm going back on this side. Remember it said up down last time? It said up down last time, right? Show interface serial 2/0, and now it is up, which lets us know layer 1 is up, right? The cabling is up, so we're good to go. And this lets us know layer 2 is up. So up lets us know is basically up. And what else we wanted to see here? The clocking. I still want to verify the clocking, even though we came for OSPF. I still want to verify that. I'm not gonna be able to sleep at night till I figure out who is doing the clocking and where can I verify that. Controllers serial 2/0. Right? He said that he is doing the DTE side. And that's his clock rate. Receive clock rate though. We do that controllers on this side too. Show controllers serial 2/0. And he don't have, yeah he do. He still says DCE. It would typically say DTE on my physical cable, on my physical hardware. And I'm gonna test that tonight just to be sure, because this don't make no sense, because the side that's doing the clocking is usually the one that says DCE, is the one that says DCE. The one that's receiving the clocking is gonna say received, and then DTE. So that's what I'm confused about. If anybody knows, is Kelvin in here? Where's Kelvin at, man? He like Encyclopedia Brown. He usually chimes in with the correct answers in the chat room over there. I guess he must be busy working on his other labs and stuff. Yeah, I guess I'll worry about that for now, for later, because we came for OSPF today, right? What else they said? We did the PPP on both sides. We did the clocking on router 1. We did the IP addressing. We turned up both interfaces. Task 3, which is the final task right here, right? We might be able to wrap this up in under a half hour, right? Enable OSPF in area 0, what we came to do, between router 1 and router 3. For router 1, we will use the process ID of router 1. For router 3, we will use process ID of 3. And I think they did that just to show you that it don't matter which process, that the process IDs, they don't have to match like EIGRP. They don't have, well, EIGRP doesn't use process IDs, they use ASNs, right? Verify that your OSPF adjacency has formed, which we'll see with log messages. You know, the router's going to spit at you and be like, hey, look, we got a neighbor. And then also verify that the default network type for the PPP link between router 1 and router 3 is point-to-point. And I think we did that already with the show interfaces command, right? No, that is not how we verified it. We do have to verify it. So let's go ahead and do that. So remember yesterday, if you guys tuned in yesterday, we covered RIP, right? A routing protocol that that needs to be buried underground because it needs to rest in peace, RIP, right? Because like I said, I have yet to see it in a production network, but they cover it in Cisco classes, in Cisco Learning Network and stuff like that, because it is one of the easiest routing protocols to learn, and it is kind of like the groundwork for learning about routing protocols, right? We got into the configuration mode by typing the keyword router and then the type of routing protocol we were going to use, which in that case was router RIP, right? Today we're going to do the same thing, but we're going to put OSPF. So we go to global config mode, terminal, and then we just type in router, right? Router, just like that. I'm going to put the question mark for the content sensitive help, and you'll see what other routing protocols we could use, right? Just like we did yesterday. We could do BGP, EIGRP, ISIS, and not the military group from Middle East, mobile routes, OSPF, RIP, right? What we came to do today, OSPF. So we just type in router, OSPF, question mark again, and we'll see it's asking us for the process ID. What did the book ask for? The book asked for process ID number 1 on this side, right? And remember, this number is locally significant. I could put 99 over here. It don't matter what the other side is. We're still going to be in the same area. We're in the backbone. So it don't matter what my process ID is. It's locally significant number, and that's what they meant by that in this book. So we just do 1, press enter, and you notice that the prompt changed from config to router config mode. It says config router, but basically this is router configuration mode. So now we can configure OSPF, and that's what we're going to do. And the way we do that is with network statements. IS, that stuff is going to blow. Man, listen, man. You using those, I don't even know, man. Who the hell calling me on my work phone at 8 o'clock at night, man? I do have a change tonight, though. But that ain't who I think it is. So I'm pretty sure that's one of them spam calls. But anyways, that stuff is gonna blow. He said 6 feet and under. For real, man. Like RIP, man. I have yet to, like I said, we have. If there's anybody new in here, let me know. Have you used RIP in a production network? I have yet to see it in a production network, and I keep saying that. I am consoled into. Y'all give me a second here. Forgot to turn my light on here. Newbie streamer here. Slow that down for y'all. That's the girl for y'all. Let's do the girl today. Where is she? Where's the girl at? Oh, that's the random one. That's why. Damn. Turn that off. We'll use the girl today. So the way, remember what we said about routing protocols, right? Routing protocols are, can y'all see me still? Yeah, okay, good. So routing protocols is a way for us to share routes with other routers, right? So remember we said we have all these destination networks that we need to get to, right? And when we have these networks, we use these we have these destinations. We have this list of destinations that we can get to and how to get to them. We share them with other routers, and that's what routing protocols do. Well, how do we do that? They have to be in our area, for one, for us to share it, and then we have to broadcast it out of our interfaces. How do we do that? With network statements. So these guys are in the network, 172.16.1. This is the 1.0 network. Let me verify that. Let me verify that. I don't think that's a 1.0 network, is it? Let me verify that before I because it's /26.1, and it's every. We got to come up with the damn magic number again. It's every 128. Let me see. It's every 16 networks. Hold on, y'all give me a second. I got to do some mental subnetting here. Slow-mo, bro. That's the girl for y'all. I think that is every 128, 64 networks. Either way, yes, it is the 1.0 network. So we type in the network statement 172.16.1.1.0, right? And then, I'm sorry, Fat Finger Squad, 1.0. So basically, we're saying broadcast OSPF out of this network, right? So I think we only need one network statement for this guy. So we're gonna broadcast, since this interface is in that network, we're gonna broadcast OSPF out of that network. I mean, out of that interface. So this interface will participate in OSPF. That's what's gonna happen when we do this, right? But we also have to do what's called the wildcard mask. So what was the subnet mask? /26, which is what? 255.255.255.192 is what it was. So that is a subnet mask, right? But we're not dealing with subnet masks when we're working with OSPF. We deal with wildcard masks. So it's kind of like the reverse of a subnet mask. I know this might be a little tricky, and it might throw you off, and your mind might be blown if this is the first time you've seen this before. But basically, what you're doing is you're matching numbers with it. But it's hard to explain. Geez, how do I do that? How do we say this? You want to say, if you want to match this subnet, this part of the subnet mask, you're going to put a 0 if you want that exact number. But in this case, we're going to do the wildcard mask will be 0.0.0, right? That lets us know, please match this exact number for the subnet. So in this case, those first three 255s, right? We want that to be the exact part of the wildcard mask. Now this part right here, it says 192, but we need the second half of the wildcard mask. Jeez, that's hard to explain, man. I can't even. that's hard to explain. I don't even know how to explain that part right there. And it's not 192. So what you got to do is you got to do 255 minus that number to put the last part of the subnet mask. So let me go ahead and put up a calculator for y'all. 255 minus 192. That's the subnet mask for. The wildcard mask for that subnet mask, if that makes any sense. That's the best way to do it, yeah. So you do that number, 255 minus whatever number you want to match. So in this case, I did 255 minus 255, which equals 0. Same thing for the second octet. So 255 minus 255 was 0. 255 minus 255 is 0. 255 minus 192 is 63. That's why the wildcard mask got to be 000.63, right? Question mark for the context section of help, and it'll tell you that you need to set the area ID. Well, what's the area ID in this case? Y'all remember? Area 0. So that's letting us know to make this interface, or make whatever interface you have that fall into this network, have them participate in OSPF in area 0, and that's what we're doing here. I hope. Yeah, there you go, Paul. So he got it. So it's every 64 networks. Okay, yeah, okay. But either way, it's .0 though, right? I hope I win. I'm not leading y'all astray here, but yes, it's 255 minus the number. That's what you got to do. Which in that case, it's 255 minus 192. Not oh yeah, that's what I did, right? And it's every 64. So yes, but yeah, either way, you got to put 63. So area 0, right? I hope I ain't losing some of y'all, man. If y'all have any questions, man, Paul B is a very smart dude. He will play like he's not smart, but he will let you know how to do it. And yes, you see, that's how you get the wildcard mask, 255 minus the number. So that's pretty much it for that routed statement. We can verify our work with show IP protocols, right? That lets us know who is participating in the EIGRP. OSPF, I deal with a lot of that at work. That's why. So once you do show IP protocols, we'll see that we have OSPF-1. This is the process ID for OSPF-1, right? Here's our router ID. The router ID is determined by the highest IP address that is on this router. There's only one IP address on this router. We do show IP interface brief and exclude unassigned. There's only one IP address here, right? And it was that one right there. So that becomes our router ID. If there was another router that is participating in OSPF, and it's like, say, 198 or 192.168 something, then that would be the router ID. It is a higher number. Or it's usually the highest loopback. It's usually the highest loopback first, and then the highest IP address. So in this case, we only have one IP address on it. That's going to be the router ID. What else we want to say here? The number of areas in this router is 1, which was what? Area 0. Stub networks and normal and NSSA, I'm going to cover that in another video. I don't want to throw too much at y'all because this is the first video we did for OSPF. Well, I've got a couple OSPF videos on this channel, but this is the first live lab we did. What else we got here? This is the router this is the network we're routing for. And the administrative distance for OSPF is 110. We could also verify our work with show IP OSPF. If you do neighbor, we'll see we don't even have no neighbors. Why? Because we didn't enable his OSPF yet. We got to do the same thing we did over here, right, with this network statement on the other side. So we got to put that. Oh, and we also have to put enable router OSPF on that other router. So what else we needed to do? We could also verify our work with show IP. There's a whole bunch of them. You can do OSPF database. If you just do show IP OSPF is what most of them start with, right? Question mark, you'll see right there. Statistics, neighbor, database. If we could just filter it down to one process ID. So remember, it was 1 for this one, right? Next one's gonna be 3. So if you do show IP OSPF 1, and we have information for that process. You can have more than one process of OSPF on the router. This is process 1. Right? It's been up for, is that how long it's been up for? No, it's been up for 21 minutes, right? That's how long I've been talking shit for? I don't know. Let's see. OSPF 1, 2122. No, that's not what it is. You can see how long it's been up with, I forgot how you could check. Statistics, probably. Or maybe it's that right there. No, that's when the last algorithm. So, yeah, that's another thing, too. So OSPF it stands for Open Shortest Path First, right? It uses this algorithm, like this math problem, called the Dijkstra's algorithm. It was by this. I want to say he's a German physicist. I can't even remember. He's a mathematician. His last name was Dijkstra, and he created this like algorithm that comes up with the fastest way to get somewhere using this like math problem, right? So we have like 30 routers, or maybe like our destination is like 30 routers away, right? Well, this math problem, the OSPF or the Dijkstra's algorithm, will figure out the fastest way to get to that 30th router, and that's what it is. And sometimes it's called the shortest path first algorithm. It gets executed by the router every, I don't remember how many times. And that's y'all pop quiz for the day. Anytime I don't know an answer, I'll be like, yes, y'all pop quiz for the day. How often does the SPF algorithm get executed on a router? But it does tell us how long ago it was and how many times it got executed. One time. If I run it again, we'll see OSPF run just one time. I think if you clear it and then run it again, it'll run it again. But let's see. I'm pretty sure Paul B know the answer to that. I'm tired of this girl. I like my regular bruh guy. All right, so let me move on here. Task 3 was we needed to enable OSPF on the other router, right? We did enough show commands there because there's a lot to wrap up with OSPF. OSPF is a very, very deep subject, right? I'm just kind of giving y'all a high-level overview with just 2 routers here. But anyways, so router 3, we needed to do router OSPF. The process ID is 3, and I think they did that to show y'all that it don't matter the process, that the process ID is locally significant. We can have process ID 1 on this side and process ID 99 on the other side. They could still become OSPF neighbors. And remember, they have to be neighbors for them to share routes with each other. He's not going to share routes if he's not a neighbor. So just think about the person that's walking out of the house, and they got to say hello to each other too. That's another concept. They say hello to each other every, I believe, 3 seconds by default. And then once they say hello to each other, they become neighbors. It gets deeper than that, but that's what they typically do, right? And I'll even show y'all when we'll probably run a debug or whatever to see that. So configure terminal, And remember what we said to enable OSPF. We got to go to router config mode for that, right? So router, we put the keyword router, OSPF. They said they wanted process ID what? 3, right? And they did that just to show you that the number is locally significant. It don't matter the process ID is. It's locally significant on that router, right? We put our network statement, which in this case was 172.16.1.0. And then the wildcard mask, which is 000.63, right? Because we did the math. Area 0 is what we're going to participate in. So what this network statement, we're saying any interface that you have that fall into this network, with this wildcard mask, right? So we only have one interface, and it does fall into it, right? It's 172.116.1.2, which falls into that network right there. Any interface that falls into that network, have them participate in OSPF, process ID 3, in OSPF 0. That's what we're saying with that network statement, right? Press enter, and we should already see where the router's already spitting at us and let us know we're participating in OSPF. So we're participating in process 3, right? We got an adjacency chain, so we formed an adjacency here, basically, right? That's a beautiful thing there. And then we said it's changed from loading to full. I wish I would have ran some show commands so y'all can see the process of it forming an adjacency. But it's like I want to say 6 levels before it forms an adjacency. First it goes to initial, right? Because he's like, oh, he says hello, and he's like, they try processing, they start sharing routes with each other, and then they be like, oh, you got some routes? Hey, yeah, let me get the route to this network. He's like, yeah, do you have this network? They start basically sharing routes with each other, and he's like, hey, are you the designated router for this network? Yeah, and then they start, and then after that they become, it goes into full. I need to bring up a chart. SPF should not be calculating once the topology is stable. So I guess if you have a high SPF count, it may indicate network flaps and link issues. That's correct too, Paul. I mean, both of y'all right, Mario and Paul, I believe, for sure. Yeah, I think it won't. Let's see if it calculated that algorithm again. So notice we went to router 1, and now he said, hey, look, we got a neighbor. It went from loading to full. So I think the first state is initial, and then it's like loading, and then X start, and then X, I can't even remember what they all are, X finish or whatever, I don't even remember. But the last, you want to see full. And we verify that with show IP OSPF neighbor. Remember we did neighbor last time, right? We ran neighbor last time, and where is that at? I did it somewhere. I don't see it. Yeah, we ran neighbor last time and we didn't have no neighbors, right? And then this time we did show IPS OSPF neighbor, and we'll see the neighbor, right? So what's the neighbor? 172.16.1.2. That's not me. I'm 172.16.1.1. He's 1.2. So that lets him know, okay, that's the neighbor. That's his ID. And remember, the ID is the highest loopback address. If there's no loopback, it's the highest physical address. Which there was only one interface there, and that's the address. That's why he did. I forgot what a priority meant. I'm not going to make pretend I know or remember. Full lets us know that we have become neighbors, right? Because remember, there's different levels to it. There's levels to this, right? It's the initial or init state, and I believe it's like X start, and then I don't remember what they all are, but once it's in full, that's when they become neighbors. The dead timer is basically how often he says hello, right? He says hello. If he haven't heard from his neighbor 4 times the hello, whatever the interval is, then he considers his neighbor dead. I believe by default, OSPF, the routers say hello every 4 seconds, right? If I'm not mistaken, he says hello every 4 seconds. 4 times the hello is 40 seconds. If I haven't heard from my neighbor in 40 seconds, I'm gonna consider him dead. It's kind of like that old guy down the block, right? We try to check on him every 40 seconds in this case, or every 4 seconds in this case. If we haven't heard from that old guy down the block, we're gonna consider him dead. And we're gonna have to call the funeral home and all this other shit, right? And find out his next of kin. That's what the dead timer is, right? So we check again. I'm gonna run that command again, y'all see, right? Dead time is 33, 31, right? I'll keep doing that, right? And I believe it's every 40 seconds. Run a debug and shut down the interface and re-enable. Yes, we'll be able to see the. That's a good idea, Paul. We'll run a debug and then we'll shut it down. But let's finish the lab first, and then we'll do that. In case y'all want to hang over, in case anybody wants to hold over and see that process, right? What else we wanted to say? That is the address of the neighbor. That's the physical address. So that's the physical address, and that is the neighbor ID. So them two ain't got to be the same. He might have a different interface address there, but his neighbor ID is actually this right here. Let's run that again, right? It started over. I wish I'd have caught that before. Yeah, so I believe it's 4 times the hello. He says hello every 10 seconds, and it's 4 times the hello, if I'm not mistaken, by default. Show IP OSPF. What else could we do? Timers, maybe? I believe it's timers we can see that with. Nope. Timers, LSA group, rate limit. Nope, that's not what it is. That's not what I wanted to see. That's not what I wanted to see. Border routers. That's a lot we can talk about today, but I don't want to throw too much at y'all and get lost in here. Show IP OSPF neighbor. See that it started over again and I missed it. Anywho, yeah, I believe it's every he says hello every 10 seconds and it's 4 times the hello. Correct me if I'm wrong, Paul. But anyways, so what else can we do? We can do a show IP show IP route, our favorite command, right? And he don't necessarily have any routes because they already know about these routes here. So they don't have any OSPF routes there. I thought he would have at least seen some OSPF routes, but these routes are connected. That's how they learned about them. If he had, let's say he had a route back here somewhere, and then router 3 wanted to share it with him, that's how router 1 would. But they both already know about this. This is a point-to-point network. They both know about this route. But we verified that we are our neighbors. And I think that's pretty much the end of the lab. We'll do the debug like Paul suggested. Let's see what else they asked for. Take a look at the solution and call it. Verify that your OSPF adjacency have formed between router 1 and router 3. And that's what we did with the show IP OSPF neighbor. Let's do that on router 3 also, right? We already seen that with this message right here when it spit at us, right? We could also verify that with show IP OSPF neighbors on this side as well, right? Show IP OSPF neighbor. And you'll see right there, there's a dead timer. And he says his neighbor is 1.1, right? So remember, he was .2. His neighbor is 1.1, right? Y'all remember that? And when we did OSPF neighbor on that side, he said his neighbor is 1.2. So he's 1.2. Y'all with me so far, right? What else they said? Also verify the default network type for the PPP link between router 1 and router 3 is point to point. Show IP. What I wanted to say. Hello is 10 times the dead interval. 40, you're good. Yes, okay, so that's what I meant. Hello is 10, dead interval is 40. So that's the default numbers now. That's the default numbers. He says hello every 10 seconds. Every 10 seconds he says hello. And we'll run the debug and y'all see that after we finish this, right? He says hello every 10 seconds by default. The dead timer is 4 times your hello. So 10 times 4 is 40. That's why he says the dead interval is 40. Shout out to Paul for that. So show IP, what I wanted to see. They said they wanted to see the default network type, which I believe if we just do show IP interface serial 2/0, the default network type. He said they wanted to see if it's point to point. That's not where it's at there. Maybe it's just show IP interface. Show interface and then that number. Show interface serial 2/0. We definitely verified that that's the encapsulation, but that don't necessarily mean that's the network type. So let me see what show command the book really wants us to see here. That's another thing too. I hope y'all get this book. I don't think I really explained wildcard masks very good. So get you a copy of this book. In that same lab, he explains, how I came up with this number. I know I did the math right there for y'all to see, but I don't like the way I explained it. Get you a copy of this book from 101labs.net. There's also a link in the description box of this video here. It'll take you to Amazon to get the book, and it's an affiliate link, so I do get commission from it. Paul Browning is the author. It's co-authored by Farai Tafa. So if you want a deeper explanation or an explaining somebody else explain it, check the book out. It says here, unlike EIGRP configuration where wildcard masks following the network statements are optional, in OSPF you must use a wildcard mask with network statements. To determine wildcard mask, you can simply subtract the network mask for the network on which you want to enable OSPF from the broadcast mask, which is what we did with this calculator here. That's how I came up with that last octet, 63, right? So you subtract that number from 255. In our example, so he just explains on how he came up with the wildcard mask. And then the last note they was, okay, so they did show IP OSPF interface. That's how you can verify the network type. So I forgot about that one. So show IP OSPF, right? And then the interface that's participating in OSPF, in this case is serial 20, right? So serial, my bad, interface serial 2/0. That show command would let us know this is the network type in OSPF, point to point. I believe the next lab, which is lab number 48, is configuring OSPF on broadcast networks. And then you'll see that's going to look different there, right? So that is how we can, that's how we verify that it's a point-to-point network. Not with this right here. Not with this PPP that I showed y'all earlier. Where was that at? That's the encapsulation type, point-to-point protocol. But this is the network, point-to-point type of network. That's the network type, right? Process ID was 1. That's the router ID. And I think that's pretty much all they wanted to cover. So we pretty much wrapped this lab. If y'all like what y'all see, you know, leave a comment down below. Run me with that like button, man. Subscribe if you're new to this channel. If you want to hang on while we just do a little debugs and just as a bonus, so we can see the breakdown of the neighborship, we're just gonna shut down the interface, run some debugs, and see the process of what they do become neighbors. We'll even see how many times he says hello and stuff like that. So, comment, like, subscribe to the network. Go ahead and hang on if y'all want to. If y'all want to also join the Discord server, sometimes I talk a little bit more shit over there. Join us on the Discord there. We pretty much wrap this lab up like we normally do at an hour. So let's do this. We wanted to do before I shut it down and look at the neighborship, I wanted to see the hello, right? So if y'all know anything about debug commands, y'all remember how the router was spitting at us and be like, hey, look, we got a neighbor, right here, right? But that only happens on significant, not necessarily significant, how I want to say, yeah, significant events, right? But you can turn on debugging to see every little process on your router, right? You can say, hey, I got a packet. Hey, something got shut down. You can set the router to spit at you more, if that makes any sense, right? It lets us know everything that's about, but you want to be careful with debugging commands. You can crash your router, especially in a production network, because there's so many things that's happening on a router, right? You can take down the CPU. You can take down a whole network with debugging commands, right? Luckily, this is the labbing environment, and we can do that if we want to, right? So you type in debug, and you can see, you know, every little process that the router is doing, right? So what we wanted to see was how many times or how often it's saying hello, instead of doing like what I was doing earlier with the show commands, be like, hey, you know, is it hello? Oh, there was the defaults right there, like I was mentioning. That's the reason why. So you do show IP OSPF interface right there, and that's the intervals that I was looking for. Timer intervals configured. Hello every 10 seconds, dead every 40 seconds. And then we're going to wait 40 seconds, and then we're going to retransmit again to see if he actually is dead, right? And we're going to check again, right? So again, it's like that old guy down the block. And we checking on him. We saying hello every 10 seconds. Hello, old man. And he says, hello. And he responds to us back. We say it again, hello. And he responds to us back. We say hello. We haven't heard from him. And then we're going to wait 4 times that hello, which is 40. If we haven't heard from him in 40 seconds, we're going to consider him what? Dead. And I believe it actually tears down the neighborship, if I'm not mistaken. If it does that, right? I don't remember. Or is that EIGRP? Yeah, EIGRP actually tells you, says it actually gives you goodbye messages. Like he actually says goodbye. It's crazy. But anyways, debug, I want to say IP OSPF is the command we're looking for, and we just say, what's the command we want to use here? And notice I'm using question mark. I ain't gonna front for y'all. I don't know every command. There's a million commands on the router. I don't know all of them. So we could do events. That'll process every OSPF event if we want to. We could do the adjacency events, which is probably what we're gonna do. I want to see, we could do just packets. That's what I wanted to see. Hello. Now we're going to see how many times he's saying hello to the old guy down the block, right? So let's go ahead and do that one. That's going to turn on debugging for this router, right? And we can turn it off if we want to. So we do debug IP OSPF hello. I didn't need to do no pings because we're directly connected. We wasn't sharing no routes. So that's all they wanted us to do. Let me go back and do that and check again. Remember, we wrapped up this lab. If y'all want to go ahead and continue studying or, you know, live your life, unlike me, who's over here labbing at 8 o'clock, 9 o'clock at night because I ain't got no life. Y'all know I just love this shit. But anyways, what I wanted to see here, that's all they wanted us to do with this lab. Yeah, that's all they wanted us to do. I'm not going to read y'all what the notes are and stuff like that. If y'all want to do that, get you a copy of this book and you can follow along. So now I'm going to press enter. We'll see now the hello events or the debugging is turned on with that message right there, right? We're going to wait till a couple seconds. See if he says hello to the old guy down the block. And look, boom, send hello. And then we receive the hello. So we know, and then end of the processing, right? That's every how many seconds right there? 10 seconds. 2, 3, 4, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi. Y'all see that? And that's what we did right there. So we're saying hello to the old guy down the block. And we notice, it says here, what is this IP address right here? 224.0.0.5. Y'all know what that is? That's not y'all pop quiz for today, but if anybody wants to give us a little bonus right here. Remember, this is the bonus lab. We already wrapped up the lab. We typically shut it down, or we usually wrap this up in about an hour. Mario said, I've done it. Took down a router with debug commands. Use syslog, graylog. Use syslog. Yeah, you could do that. Yeah, you could take down a router, man. Don't be careful with these debugging commands, man. You could actually, man, listen. Be careful with these. So, like I said, this is just a labbing environment. We could play with this, and we only got 2 routers on here. This is GNS3. We could do that if we want to, right? But we're sending and receiving hellos to the old guy down the block. So, anyways, 224.0.0.5 is where we send those multicast messages. This is called a multicast. There you go, Paul. Multicast address for OSPF. The designated router is sending those OSPF messages using that multicast address. So, in other words, we're saying hello to select neighbors in the area. Or, how do I say that? Because multicast is not the same thing as broadcast. We're not broadcasting. So, I use that word. I use that word wrong. We don't broadcast OSPF messages. We send them using a multicast address, which in this case is 224.0.0.5. Remember, there's a difference between broadcast, where you're saying hello to everybody, versus multicast. Multicast is select people you're saying hello to. And that's what we're doing. So whoever is participating in OSPF will receive them, I believe, on 225.0.0.6, if I'm not mistaken. We might have to do the hello on this side. But to verify that, if I'm not mistaken, you received them on 224.0.0.6, right? But yes, probably his brother got it correct. It's the multicast address. So 224.0.0.5. Let's go ahead and shut that off. So that way, because remember, if you turn on too many debugging messages, it's going to start spitting a whole bunch of crap at you. So you want to turn some off, turn them on, turn them off, turn them on, right? And notice we're sending and receiving hellos from 172.16.1.2, which is that guy right there. So the old guy down the block is answering us, basically, right? So let's go ahead and no, we ain't got to go to global configure mode. We can just turn that off. So we can just do undebug. Oops, come on, man, undebug, right? And then we could just do undebug what we said, IP OSPF. So in this case, excuse me, you can do undebug all and it'll shut off every debug message, or you could do undebug the specific one you turned off or turned on. So in this case, we're gonna undebug IP OSPF hello messages. So we turning this off now. Notice it says that right there. So now he gonna stop. He's still saying hello in the background. We just not getting the messages on the router. Because remember, we're using our CPU when we're doing that by putting it on the screen there. But he's staying saying hello in the background. So he checking on that old guy. Don't worry about him. So what else we wanted to see? We wanted to see what Paul was mentioning. We're going to shut down the interface and we're going to see the process of OSPF being the neighbors being formed here, right? So I'm going to shut this down a little bit. This was just a little bonus tidbit, right? So let's go ahead and shut down that interface. And let's run some show commands. I mean, not show commands, but what I wanted to say. some debugging on router 3, right? So let's do some debugging over here. Let's debug what IP OSPF, and we want to do the neighbors, right? Let's do adjacency events. We could do every OSPF event in there, but it's just gonna that's gonna throw too much at you, right? We did the hellos already. We could do all. I want to say this is all the packets too. I don't know what's the difference between packet and events. Oh, because not all of them are packets, believe it or not. There's LSAs, they call link state advertisements, and there's also LSUs. LSU is a packet. LSA is a message that's within an LSU. That's a little too deep. Remember I said OSPF could be a really deep subject, but that's the reason why they have packets and also events. So let's do this. Let's do which one y'all want to do? Let's do adjacency events, and then we'll check it out, right? So we're gonna do adjacency. And then let's check it out. Let's see what happens. There's no adjacency event going on right now. I don't think because we'd have to actually shut it down and bring it up to actually see all of that. Right? So let's go ahead and do that. We're gonna shut down OSPF on this guy. Not shut down OSPF. We're just gonna shut down the interface that's participating in OSPF. That's a more accurate accurate way to say it. Interface serial 2/0. Right? We're gonna shut that bad boy down, and then we're gonna go to router 3 and look at the messages that was going on here, right? So let's go ahead and shut that bad boy down. Go to router 3. Check out the adjacency events. He gonna say hello at that 10th second, right? Come on, router 3. Did he tear it down yet? He should have tore down the did I press enter? Yeah, I did. Interesting. I should have done just all events. We should have turned on the neighbor adjacency right there. What's going on here? I ain't even showing myself here. There you go, right there. Y'all notice this right here. 172 020/0 is dead. So now we consider that old guy down the block. I got such a morbid sense of humor. That old guy down the block is pretty much dead now, right? And notice it says right here, 2/0 went from full to down. If you know anything about OSPF, when we start to create a neighborship, it goes to what's called the init state, initial, right? We're initiating a neighbor adjacency. That's what the INIT stands for. Let me pull that up. Exit the interface. I could have done that too, I guess, but it was there. It's just that it takes a little bit before he considers him dead, remember? So we got to wait 40 seconds for us to consider our neighbor dead, and that's what happened there. Man, I'm sorry, y'all. I hope ain't no old people or some elderly people watching this like, man, this dude, man. Anyway, what I want to do, I wanted to bring up he said use BFD. What you mean? What you mean, Mario C? BFD? I might have to, let me see. You using them internet terms, man? I don't even know. What you meant by that, Mario? Oh, detection protocol. Forwarding path failure. So there was no path failure. It's just that we had to wait 40 seconds to consider him dead, is what it was. What I wanted to bring up, though, is the states of OSPF, right? Which I'm pretty sure some of you guys know already. Maybe some of y'all don't. Maybe some new people in here. If y'all have any questions, man, don't hesitate to ask. I'm learning along with you guys. Yes, I took, I got my CCNA and stuff like that, but I'm just filling a lot of gaps in my knowledge and stuff before moving on back to my CCNP studies. We're gonna look up the OSPF states. Was it the states that I wanted to show y'all? Neighbor states. There they go, right there. So the first state is down, right? And that's what we did. We went backwards though, because remember, he went from full to down. Now, if I bring up them states there, let's bring that up. This is official Cisco documentation too. Let me bring that up over here. Right, these are the states, right? Down So init was, I'm wrong by that. That init is not the first state. That's the first state you might see in the messages though. So you consider your neighbor down before you become a neighbor. Then you make an attempt to see if he is actually an OSPF neighbor, or if you have any interfaces, if he has any interfaces that's participating in OSPF. And then after that, you initialize a OSPF relationship, right? Here's go to the definitions right here. If y'all want to, I'll put this link in in the chat room if y'all want to read that on your own time. If y'all ain't got no life reading RFCs and goddamn Cisco documentation, y'all could do that if y'all want to. Let me put that in there for you. What's up, Danielle? Danielle likes to read OSPF documentation like me as well. So, bi-directional forwarding. Okay, appreciate that, Mario. So, we said init is this state specifies that the router has received a hello packet from its neighbor, but the receiving router ID was not included in the hello packet. When a router receives a hello from the neighbor, it should list the sender's router ID in its hello packet as an acknowledgement that it received the valid hello packet. So, we're going to see these states once we bring it up. And after that, I'm going to call it a night. We already finished lab. Like I said, this is just the bonus part for some of y'all that just tuned in late. Typically we wrap these labs up in an hour. That's how it's been so far. This is just a little bonus. We kind of like doing a little deeper dive of the OSPF neighbor states, right? You can get a copy of this book from 101labs.net. I promote this bitch like it's like I wrote the goddamn book. It's authored by Paul Browning and Fried Tafab. There's a link in the description box below if you want to get a copy of that. That's an affiliate link. And also that link that I put in the chat, that will take you to this OSPF neighbor states document that we're discussing right now, right? So we turned on debugging and we saw we considered our neighbor that we checked on down the block, or as Danielle would say, our olds. We checked our olds down the block to see if he's all right? And now he's considered dead at this point. We went from full to down. What are those states again? Down, attempt, init, two-way, xstart, exchange, loading, full. When you become full, that's when you're neighbors. We went from full to down, and then we considered them dead, right? Notice that right there. Notice full to down. Dead timer expired. Remember, by default, you say in hello every 10 seconds, and 4 times the hello is when we consider our olds or neighbors, our old guy down the block, dead, right? And then OSPF right here, we got another message right here. Build router LSA for area 0. Remember, LSA is link state advertisements. That's like messages that we use to find out about more routes from our neighbor and stuff like that. They're called link state advertisements. And then this message right here let us know that the serial interface was down. State was down. And that's pretty much it. That's all they gave us there. I don't like that one. That's just adjacencies. Maybe we should just do all the events. I just know that the router's just going to spit a whole bunch of stuff at us. That's why I didn't want to do packet. But yeah, let's go ahead and bring it back up and take a look at that. So we're going to bring it back up. Let me clear this for y'all. You can't do clear screen on a router. Just press enter there, right? And then let's go ahead and bring that interface back up. No shut, right? And then we're going to look at those events again. Let's do packet this time, though. We're going to undebug IP OSPF. What we did adjacency, and now we're gonna turn on every OSPF message that we can see there. So we're gonna say debug IP OSPF question mark for context sensitive help, and we'll see we did hello already. Excuse me, we did adjacency already. When you say states, you mean you're not. You trying to be a comedian over there. More OSPF. Yes, Calvin, we're doing some more OSPF today. This is the first time that the book actually introduced OSPF, Calvin. We're just kind of, we already wrapped up the lab. We're just kind of going over the neighbor states and doing a little bit debugging. So this is just a little bonus that we're doing. We already wrapped up the lab at around 8:55. So let's go ahead and do OSPF packets, and we'll take a look at those packets, right? So now we're turning on the packets. Is he gonna say hello? I think they're gonna still show us some hellos, because that might be a little too much. Let's see. Being that OSPF is not, there's no, we do have an interface that's participating in OSPF, but he's not going to receive any messages there. So, and we already considered our neighbor dead, right? So let's do that. Let's go ahead and turn on that that interface. So basically, we turn this interface off, and then he said, okay, that router must be dead. That old guy must be dead over here. So he considered him dead, and is no longer they're no longer OSPF neighbors. We're gonna bring that interface back up, and we're gonna go on router 1 and see those OSPF messages, right? Let's see here. What was gonna do? Yeah, we're gonna go to router 1. No, shut that bad boy and take a look at router 3. Did we did the packets? Yes. Okay, so we're gonna turn it on. Press the red button. Go to router 3. We gotta see. This is why I didn't want to use that one. See, no, it went from loading to full. Right? Remember what we said about those states, right? Loading to full is where it went to. And that was pretty much it. That's all it gave us. Interesting. But he did, let's see, we got some, we received an OSPF message there. That interface came up. It went from loading to full. But I don't see the, I wanted to see like init and all of those other states. You know what I'm missing here? See, now we're doing too many. Now we're showing all of this other stuff. Like how many times he's saying hello and all this other stuff. I ain't want to do all of that. OSPF is popular, I find, more so than ISIS. OSPF will be around for a long time. So much interesting history behind the protocols of law. Yes, it is. OSPF is very popular. I noticed from the last 2 organizations I've worked for, though, they use EIGRP. And EIGRP is Cisco proprietary, and a lot of organizations has used Cisco devices, Cisco in their infrastructure. So that's why they usually opt for EIGRP. But yeah, I haven't really seen ISIS in the production network either. But then again, I haven't really worked in yeah, I've worked for large organizations. I work for a large hospital and university. So I think ISIS, is that something more you would more see on in an ISP? Kelvin, can you let us know? BGP, OSPF, EIGRP in that order. Yeah, I agree. But BGP is more of an external gateway protocol, right? You're not going to see that internally. So that's like comparing apples to oranges. But yes, good point, plant-based brother. I think that's pretty much it. I wanted to see the init like we saw before and stuff like that. Let's do the other packet real quick. And I'm going to shut it down and bring it back up. Let's turn it off. Undebug. We can do undebug all, so we can turn everything off, right? Because I didn't want to see that. And we're going to shut it down, and I'm going to do, instead of packet, I'm going to do the other one. So I'm going to shut that bad boy down, right? Damn, I should have turned that on. So, let's do this. Debug, IP, OSPF. Let's do packets this time. Did I do packet last time, or did I do events? I did events last time. Let's do packet this time. What did I do last time? Did I do packets or events? I can't even remember. I did packet last time. And now I'm doing packet again. Come on, man. Come on, Vlad. Come on, Vlad. So now he turned him dead. Undebug that. What I wanted to do was debug OSPF events. Let's do that. Because I did packets last time, right? Yes, I did packets last time. Right? So now he's sending hello. So now we're doing all the events right there. So that interface is going down. That OSPF is going down. Right? That's the difference between this one. This was the interface log message. This is the OSPF interface log message, letting you know it's going down. Let's see if there's any other messages when we bring it up. Again, that document is in the chat in case you want to see those states. Remember, this is the states before they become neighbors. First, they consider the neighbor down. Before you even meet him, he considers him down, right? Then he makes an attempt to become a neighbor. Init, two-way, xstart, exchange, loading, and then become full. Once it's full, that's how you know they become neighbors, right? They don't necessarily have to be in full, though. Because if they're not a designated router, or if it's not a designated router, it's not going to be full. So if you notice right here, full, in this state, routers are fully adjacent with each other. All the other routers and network LSAs are exchanged, and the routers' databases are fully synchronized. Full is the normal state for an OSPF router. That's what we want to see. That's exactly what we want to see. When we see full, that's how we know it worked. That's what we want to see when we do that. So let's bring it back up. no shut. Take a look at the events there on router 3, and let's see what happens. That's what I wanted to see. Events. Was that events or was that packet? I can't even remember again. I got a short-term memory. Events. So we brought it up, right? Serial interface went up. That's what I wanted to see. Events, right? And then we send a hello to the neighbor through the multicast address. Damn, let me see. It's going to keep coming. So we sent hello to the multicast address. We received a hello. We sent an immediate hello to the neighbor. Damn, I got to bring this up. Let me bring this all the way up so y'all can see. Right? Bring this up. So we sent a hello. We received a hello. We sent an immediate hello. Bring that back up again. Let me turn this off. So end of hello processing. So let's turn that off right now. So let's turn that off. Undebugged events, because it's just gonna keep spitting at us. And let's go ahead and dissect these messages, and we're gonna call it a night. Right? So we brought the interface back up, right? Then we sent the hello to the multicast address, right? That's the OSPF multicast address. Area 0 on that interface. What is that? That's the only interface we have on there, right? Right there. From 172.16.1.2. That's our interface, our local interface, right? Then we received a hello on our local interface. Who did we receive it from? 1.1. Who is that? That's, come on, man. That's this guy right here, 1.1. That's who we received the hello from, that old guy down the block. We sent another immediate hello to that guy. That's our source address. And then the hello of processing. And there goes some of the messages, some of the states that I wanted to see here. We went in the two-way state right there. Two-way communication. What's that? Go to that documentation. We'll see. Two-way is. We go to that documentation, and two-way is right there. This state designates bi-directional communication, which is what Mario C was mentioning, has been established between two routers. But that don't necessarily mean we're neighbors yet. Bi-directional means that router has seen each other's hello packet. So the old guy I said hello to the old guy. The old guy seen that packet, and the old guy said hello back to me. Now we're in two-way state, right? This state is attained when the router receiving the hello packet sees its own router ID within the received hello packet's neighbor field. At this state, a router decides whether to become adjacent with this neighbor. I'm not gonna read all this to y'all. I gave y'all the documentation in the chat room there. If you want, go ahead and read all of that. And then, but that's basically what two-way is. Let's finish. That's the documentation again. If y'all want to read the rest of that. So we went into two-way there. We prepared a database exchange. So with that old guy, we shared some routes. Be like, hey, look, man, if you want to get to this network, you know, here's a way to get there. And then the old guy knew some routes, and he gave it to us. We're on a point-to-point network. They don't really have any routes to share, but that's what we do typically if we had some other routes to share, right? What else I wanted to discuss here? First DBD, so that's the database, what's that? Database, designated database? I can't even remember what that stands for. Database, what is that, Kelvin? I'm sure Kelvin knows what the DBD stands for. We are not slave. So, that's the other one right there I wanted to say. Xstart. What's Xstart? That's also in the documentation. Once the DR and BDR are elected, so we're defining who is the designated router. Designated router is the guy who's going to be giving link state updates to everybody else. Border designated router is the one that's on the border of between routers. So if we had, between areas, if we had like say area 10 right here, right, and this is obviously area 0, and there's a router that sits between those two routers, he is going to be the area border router, right, ABR. They wanted to say the border designated router. Just what I wanted to say. That's the area border router. What I wanted to say was the BDR is the border designated router. What's the difference between the two? Shit, can't even remember. I can't even remember. But that's not ABR. That's what I meant to say. That what I was explaining right here. That's the ABR. That sits between the two routers. BDR is the backup designated router. That's what I wanted to say. So he's the backup designated router. So the designated router is the router that's giving everybody updates. He carries the main list of all the routes. The backup designated router is in case the designated router goes down. That's what BDR stands for. So my bad about that. Database descriptor. So that's right. Kelvin got it right. That's what that's what I meant to say right there. Contains the LSA headers of all the LSAs in the area's SPF database. So yes, and yes, Kelvin got that right too. The backup designated router. That's what I meant to say. It's the backup designated router. What was I saying there? Got them two confused. So backup designated router is the guy that takes over when the designated router is down, DR, right? So that's the difference between DR and BDR. What else I wanted to say? So we had Xstart. That's the other state right there. And then after that, we did some exchange. We did some updates. We got some LSUs and stuff like that. And then we went from loading to full. And again, if y'all want to breakdown of what all of those states are, I put the link for this Cisco documentation in the chat there. We went from loading, basically, and then we went to full right there, which is what we wanted to see. That's when we become neighbors, when we're in full state. I think that's pretty much it, man. I wrapped it up. Kelvin, thanks for your help. He gave us a lot of information there. If y'all want to go ahead and check him out, his YouTube channel. He has an excellent YouTube channel as well. Y'all want me with that like button if y'all like what y'all see. I think I'm gonna wrap it up. Kevin, can I borrow your brain? Yeah, seriously, man. Kevin got all these damn fun facts in his head. What do you do? Like a damn mathematician or a genius or something, man? This guy knows all this stuff. But anyways, y'all check him out on his channel right there. What else I wanted to say? If y'all want, go ahead and join us on the Discord server. If I'm ever late or if I have some new updates or something like that on my channel, I will share that information in the, let me see, though I'm not sure why you're talking about DR and BDR here, seeing that you're on a point-to-point network. Yeah, exactly. It's just that I was going a little too deep. I was doing a deep dive, and I really didn't need to. This was just a after-class session, if you want to say that. That's our Discord server right there, if y'all want to join that. We talk about, stuff that are off topic or anything that's in, anything network-related. Anything career related. Plant-based brother, I'll be in that chat room in a little bit, and we'll discuss the your career moves and stuff like that. From now, please comment, like, subscribe to the network.